Use the algebraic formulas of finite sums to evaluate the following. So looking at our given sum here, the first thing we're observing is the sum of the sum, or the sum in our general formula. So we can say, by the sum or difference rule, we can rewrite this as the sum from k is 1 to 5 of 3 plus the sum from k is 1 to 5 of k squared. And so looking at this first term here, we realize that this is the constant rule. And this will be the constant rule where our n is 5. And looking at our second case here, we realize that this is the sum of the first n squares. And since n is 5 here, this is going to be the sum of the first 5 squares. So to help us out, let's just quickly recall that the sum from k is 1 to n of k squared, so the sum of the first n squares, is equal to k, or excuse me, not k, but n. So this becomes n times n plus 1 times 2n plus 1, all divided by 6. And then for the constant rule, we'll keep in mind that if we have the sum from k is 1 to n of a constant c, that becomes c times n. And so again, here we are specifically working with where n is 5. So any one of the n's in those general formulas we just recalled, we're going to replace the n with 5. So this will become 3 multiplied by 5 plus 5 multiplied by 5 plus 1 multiplied by 2 times 5 plus 1, and that's all divided by 6. And we can simplify. So this becomes 15 plus, and we can see here we have some nice cancellation. This 5 plus 1 gives us 6, which cancels that 6 in the denominator. So this leaves us with 5 multiplied by, we have 10 plus 1, which is 11. So we have 15 plus 55, which leaves us with a beautiful final answer of 70.